Welcome to Hack to the Future. Just like the movies, we have far too much to get to, and we are out of time.
So hi everyone, my name is Neil Samier. I'm a security researcher at Qodo Security. I'm a public speaker, and I'm a huge fan of Linux and open source.
My name is Nathan Hamill. I'm Senior Director of Research at Qodo Security. I lead the fundamental and applied research team. I'm a public speaker. I'm also on the review board of Black Hat. I'm the AI Machine Learning and Data Science track lead. I'm also on the board of the AI Summit. And here we go. So in this presentation, we're going to cover a few different things. We're going to show how the shifts in the mindset and anti-patterns are leading to a whole bunch of vulnerabilities. These are vulnerabilities we've seen before. How connecting things for AI is also connecting things for attackers. Also, how generative AI's use in development is changing. It's not just AI coding assistance. We have a three-part story filled with tears, and your perspective depends on whether they're tears of joy or pain, and how we gained access to over 1 million GitHub repos, possibly yours. But mostly, this presentation is about how some vulnerabilities never grow up, and some things will never change, that you're never too old for an RCE. No LLMs were harmed on this presentation, but we can't say the same for the organizations and applications implementing them. So now let's get into it. Our focus was on AI-powered developer productivity tools. And this is what you may think when you think of that. You might think of vibe coding and coding assistants. But really, the development space has kind of moved on. We've bucketed these into 3 different categories for the research we conducted. We have coding assistants, which everyone is familiar with, but also a new class of tools, which are AI-powered code review tools. And these are tools that get deployed in your environment. And also libraries and analytics tools. So these are tools that get integrated into your developers' applications. Mainly, developers are using these tools to perform tedious tasks and to outsource certain tasks to these tools. Things like reviewing pull requests, backporting code, writing documentation, and things like that. Now, I will say, we did research on over a dozen of these tools, and we found vulnerabilities in all of them. So it's kind of like pulling the lever on a slot machine and winning every single time. So if we were in Vegas, Vegas would be bust.
Thanks. So let's have a more in-depth look at 2 categories of these apps and how those work. So the first one we had a look at is AI code review tools. So basically, these tools help developers review their code using AI. So the way they work usually is a developer first pushes code to a Git provider, such as GitHub or GitLab. The provider is going to notify that AI code review vendor that new code has been pushed. The vendor will fetch that new pushed code, and it's going to run some tools to analyze that code, such as static analyzers, for example. It's going to use the output of these static analyzers and the code changes to ask an LLM to generate a code review. And that code review is going to get posted back on the Git provider, and this is where the user will be able to read it. So here I have a few examples of what these AI code review tools can do. So for example, they can help a developer explain or summarize a pull request. It can suggest changes to the code or detect security issues in the code or even generate diagrams that explain the code. The second category of apps is AI data analytics tools. So here, the user has a database with lots of data in it, and the user wants to answer questions about their data. So they first grant the vendor access to their database, and then when the user has a question, the vendor is going to get the schema of the database and use that schema plus the question to ask an LLM to generate an SQL query, which will get executed on the database, which will return some data from the database, and then the vendor will take that output plus the original question plus the schema to ask an LLM again to generate a chart which will illustrate the response that to the question the user had, which is now a happy user because they got an answer without having to write any SQL at all. But how did we even get here in the first place? So our developers internally were using a tool that was called PR Agent, and it's an AI code review tool. And we thought, well, this could very well be vulnerable, right? So we had to look at it. And later, PR Agent was renamed to Qodo Merge, but it's the same thing, right? So we had a look at the open source version of Qodo Merge, and we found two vulnerabilities in it. The first one happened when it was used with GitLab. So what we found here is that it was possible to get a privilege escalation. So for example, if you would use the tool as someone who's got the reporter role, you could trick Qodo Merge into printing a comment that would contain a GitLab quick action that would get executed by GitLab with potentially more privileges than the user had. So now, this was running as a maintainer instead. And I think this is an interesting example because it's a real-world use case of a prompt injection that leads to privilege escalation. We also found that it was possible to overwrite all of the settings, keys, and values used internally by Qodo Merge. And for that, they use a library called dynaconf internally to set key values, but we will get back to dynaconf later. And it's possible to change all of these keys and values, and especially the critical ones. So when Qodo Merge was used on GitHub, for example, it was possible to post a comment on a PR that would overwrite the GitHub API-based URL and change it to something where we could collect secrets. And that way we could leak an access token and get write access to a repository using this Qodo Merge tool. And these two vulnerabilities is something I talked already last year at CCC about. So if you'd like more details on these two, you can have a look at that talk. And I will get back to that story in a few minutes.
Okay, so hopefully with that little brief introduction, you can start to see what some of the impacts are here. So how many people heard about the Amazon Q debacle that happened last week, where somebody was able to plant computer wiping commands inside of Amazon Q's coding agent? Now, I didn't investigate this, neither of us did, but we both thought that this looked an awful lot like one of these AI coding agents that got compromised. So it's a good example of helping you start to think about some of the impacts here. There are tons of impacts, and these aren't even all of them. And the point here isn't to go through all of these different impacts. The point here is to show that you may be exposed in interesting ways. Allowing an attacker to manipulate your systems and code is never a good time. This is something we should have learned from the early days of security. So what's really going on here? Why are all of these vulnerabilities surfacing again? Well, there are widespread vulnerabilities throughout the generative AI space. And despite these vulnerabilities, people are putting these systems deeper and deeper into their own systems and workflows. And that includes your developers' workflows as well. And as you'll see, gone are the days of knowing the difference between good security practices and bad security practices. Because when you deploy these tools, you increase your attack surface, right? Deploying these tools creates new vulnerabilities where there weren't any previously. And developers are deploying these tools because they're being made some promises. They're told they could be 10x, 100x, or 1,000x more productive. So it becomes speed above everything else. And all of these products, all of these companies say that they take security seriously, but they have no security staff, no security validation, and they have no way to report bugs to them. That doesn't sound very serious. Generative AI, as you're looking at this space, generative AI is kind of like a new execution environment. It's not a new operating system, but it's something kind of similar that you might need to think about. You know, there are features and functionalities inside of generative AI that no developer programmed into them. And there's like almost unlimited undocumented protocols inside of these. That's why you can give it a base 64 string and you don't need to tell it to decode the base 64. It just does it. And this opens the door to a bunch of manipulation risks, right? So we're not used to people talking our applications into taking actions that they weren't programmed to do. We're used to social engineering humans, not applications, but that's changing. And the facts are that security professionals need to start to coming to grips with these things. Unknowns are also becoming the new normal. Developers have outsourced functional components of their applications to black boxes. And if you think about it, it's kind of strange because it means a developer who develops a product or tool isn't quite sure what code is going to execute at runtime. I mean, that is new, and that is something we also need to start thinking about. And which is a little strange because these tools are actually slower, less reliable, less secure, and more expensive, but we're seeing it happen anyway. And small changes in the inputs of these tools can lead to large changes in the outputs. So this is something to keep in mind as you're testing these tools. Another common thing that breaks with traditional information security is organizations are creating new high-value targets. So they're taking internal data, external data, sensitive and non-sensitive, and mixing them together. And they're told that if they just add AI, that money will sprout out of this architecture. But I can tell you there's a lot of vulnerabilities that sprout out of this architecture as well. We've known since the beginning of InfoSec you shouldn't mix all these together. It also allows attackers to potentially get data into your system. And once you get an attacker with ability to put data into your system, in your generative AI system, you can no longer trust the output. Also, they're now in the system with sensitive data. And although we're talking about data here, it could be tool calls as well in agent environments. So it's something to think about. We're also seeing a lot of AI all the way down, connecting AI to both data and tools, and connecting things for AI is also connecting things for attackers. So anything your AI can do, an attacker can potentially do. So think about that as well. And finally, developers are more inclined, because of productivity, to grant these tools deeper permissions, deeper levels of access. And this granting is done without the thought to the people who actually develop these tools. So these systems are acting as you, or they're acting as your developers, or far worse, maybe with elevated permissions. And we're seeing that least privilege is replaced with most privilege, and most privilege is on by default, which is also another thing that we've kind of learned not to do.
Here's an example. There was this GitHub repository that is configured so that every time a pull request is made, not just one AI code review agent runs, but 5 different code review agents. So that really increases the attack surface, right? Imagine what could go wrong if one of these is vulnerable.
So what did we find? So let's get into some vulnerabilities here. What did we find? We found a whole slew of categories and themes in these tools. And we're not going to have time to go through all of them, and we're not going to have time to go through all the vulnerabilities, but the slides will be available for download afterwards, and we have a bonus section that covers even more of these things. But this is concerning because a lot of these things are things we already know about. But one of the most concerning is blind execution of input. So what is blind execution of input? Here's an example. It's where you take data from a user, aka an attacker, combine it with some query, and execute the result. So here is a simple example of a remote code execution vulnerability on a tool where it takes user data, adds it to a prompt, it makes a request to an LLM, and then it executes the output. The funny thing here is if you just ran a tool like semgrep against the code base, you would have found this. And it wasn't caught. It is very surreal, right, to see people praising organizations like CISA for pushing memory-safe languages, and also congratulating people building tools which are basically RCE as a service. So here you can see how this kind of works. That's just how these tools work. They take user input, application output, mix it with some data or other context, use that, request to some AI service, they get code in return, and then they execute the output. So let's get into it. Speaking of RCE.
Thanks. So RCE, remote code execution. Now let's get serious. So remember I mentioned earlier that these 2 vulnerabilities I found last year in Qodo Merge. This is something I presented at CCC. And after I got off the stage, someone came to me and asked me whether I had a look at a similar tool that was called CodeRabbit. And today I would like to thank that person because, oh boy, was it vulnerable. And I'm going now to explain what we found. So CodeRabbit is the most installed GitHub app in the AI-assisted category on GitHub Marketplace. It's an AI code review app. And it currently reviews over 1 million GitHub repositories. So when you install CodeRabbit, you are presented with that screen on the left. And basically, you have the option to select on which repositories you would like to install it. So it could be just one or all of your repos if you want it. And when you do that, you're basically going to grant CodeRabbit write access to your GitHub repository. And sometimes it's not really clear what permissions you grant here. But on the installation page, it says you give write permissions to code. But it's never said on the page that when you do that, you also grant permissions to edit existing GitHub releases, for example. So once CodeRabbit is installed, it's basically going to run every time you make a pull request. And CodeRabbit is going to analyze your code, and to do that, they are going to run static analyzers on your code. And they support over a dozen of those, and one of those is for the Ruby programming language, and it's called RuboCop. And the docs of CodeRabbit state that if there's a RuboCop config file anywhere in your repository, they will pass it to RuboCop. And that really sounded dangerous to me, and that's because it was. Because indeed, you can make a malicious pull request that contains a dummy Ruby file just to trigger the execution of RuboCop. You would also include a RuboCop config file that instructs RuboCop to load a third file, for example, x.rb. And in x.rb, you would put your arbitrary Ruby code. For example, you could send all of the environment variables to yourself, right? So did it work? I'll say it worked. So there were so many secrets in those environment variables that it actually took me a whole minute to figure out what we had gotten access to here. And out of those secrets, there was this. Can you guess what this is? It's the CodeRabbit GitHub app private key. So what could we do with that? So remember, when you install the CodeRabbit app, you basically grant CodeRabbit write access to your repository, right? So if you have the CodeRabbit app private key, it means you can act on behalf of the CodeRabbit GitHub app, right? And that means we had gotten write access to over 1 million GitHub repositories, including private repositories. So we reported that to CodeRabbit, and they confirmed that they have now fixed it. We also had a look at another tool called DOT, which is an AI data analytics tool. And it looks like DOT uses your tools. That sounds nice, right? So basically, you grant DOT access to your database, and then DOT lets you talk to your database, right? And, well, oops, unfortunately for them, we found that they had a vulnerable API endpoint where you could inject a system command, and through that, we got RCE on their prod system, where we could leak their environment variables, of course, which contained credentials to their Postgres DB, and that DB contained the credentials to the databases of customers of that.
Yeah, so hopefully you're starting to see how the AI components kind of mix with the tools and systems involved. And I hope people realize just how devastating that attack was. I think we kind of like glossed over it. But we could have basically taken over all their customers, all their systems, plus used all their secrets to run up their bills. And you might be thinking, oh, well, that's silly. Just run everything in a container, right? But many of these containers aren't configured properly. We saw that with some of the environment variable stuff. But another attack that we found was web access and proxy attacks. So even if people kind of they're not leaking their environment variables, they're not doing other things like that, many of these tools have features by default. And one of those tools was called Ask Your Database, and it's another one of these, like, let's talk to your data type of tool. And it's not really obvious from the documentation, but you can execute arbitrary Python, and it was so easy it didn't even seem like it was a problem. And one of the things we wanted to do is see, okay, do we have web access? And of course, we did. So do we have access to pip? Nope. It seems they thought that constraining the environment was a good idea to stop people from performing attacks. However, if you have web access, you can just download any module you want. So no pip, no problem. So now the tools that were deployed can be used as a sort of anonymous attack proxy to attack other systems. So it's these organizations not applying appropriate security mechanisms. This is a combination of knowing the features and functionality of the application and the attacks you're looking to pull off.
Another category is SQL manipulation and injection. And one example of that was an open source tool called DataLine. And they were doing something you should never do, which is security in the prompt. So they were basically politely asking an LLM to never generate SQL statements that modify the database. But of course, you can trick that to generate something that actually changes something in the database, like a drop table or whatever. So never do security in the prompt. And that brings us to excessive actions, access, and permissions. And let's get back to the story we left off before. So after we wrapped up the CodeRabbit research, we noticed that the developers of Qodo Merge actually pushed a fix to block our exploit. And what they did is they added a list of forbidden words that you couldn't put in the, let's say, in the GitHub PR comment, for example. So it was not possible anymore to put .base URL. So of course, this blocked our exploit, but as you can guess, it didn't fix the root issue here, right? And we thought, well, we can bypass that. And remember I said they used something called dynaconf internally to manage keys and value pairs. And it's not just for setting and getting key values, but it can do more than that. So there is special syntax in dynaconf where you could actually transform a string into a JSON object or evaluate a Jinja expression. And this is really dangerous, right? So basically, we could rewrite our exploit, which was this initially, into something that uses the dynaconf syntax, but that does not contain the blocked keywords. And it would still exploit the system, right? So we told them about that, and they pushed another fix. And now, what did they do? Well, they blocked another keyword, .user. So, of course, it blocked the second exploit, but it didn't fix the root issue, right? So we rewrote the bypass into this. And it also exploited the vulnerability again. So security is hard, and properly fixing security issues can be hard. I mentioned we had a look at the open source version of Qodo Merge, but they also have a paid or SaaS version of it called Qodo Merge Pro. And we had a look at that. And there is one feature in that tool where if you write on GitHub a comment on a PR that says /config, then the tool is going to reply with another comment that contains a dump of all of the key values in the Dynaconf object, which are not considered sensitive. So supposedly no secrets, right? And we thought, well, there should be a way to exploit that, right? So let's use some Dynaconf special features for that. And basically the trick we used here is we placed a Qodo Merge config file at the root of the repository that basically instructs Qodo Merge to print all of the environment variables in a key value pair, which is not considered sensitive. And then we ask it to dump all of the key values again. Is that it? Do we have all of the environment variables already? Well, yes. They just appeared in the GitHub PR comment. And what did we find in there? Well, we found an AWS secret key, and not a regular one, a very leet AWS secret key. And not just because its value starts with /leet, but because it has very leet permissions. Can you guess what permissions it had? Of course. So administrator access. So you could do everything on their AWS infrastructure. So at that point, it was pretty much game over for them. So we could do anything. We could even have gotten access to repositories of users of Qodo Merge Pro. So security is hard, and permissions can be hard. In the end, they fixed it in a proper way, which is to disable the special Dynaconf features. And we thought, well, if there are those vulnerabilities, there should be more, right? So we had a look at another tool that that company makes, which is called CodeGen, and it's an AI coding agent that comes as a VS Code extension. And that agent has tools, and one of these tools was not properly sanitizing its parameters. So you could basically give it malicious instructions that would trigger the execution of that tool with parameters that would run a system command. And in practice, the way that could be exploited is you could publish a public GitHub repository that contains a README file with malicious instructions, potentially even hidden to the user with Unicode special characters. And that user would download your GitHub repository, open it with CodeGen, and since the user is usually lazy and don't want to know how they can use your tool, they would ask CodeGen to follow the instructions in the README file. And if they did that, it would call that tool and execute the command. And boom, the command would be executed on the user's machine. So now they're sharing RCs with everyone. It's not just on their POS system, but also on your machine.
RCEs for Christmas, on their systems and yours, yeah.
So in the end, Qodo fixed all of these issues, and they are taking security very seriously, and they are very motivated to improve, so kudos to them for that.
Can we take a moment to just realize the terror that must ensue every single time they see Niels' email address in their inbox in the morning? And we're being kind of nice. We met the CEO, and he's a very nice guy, and we kind of felt bad for a joke we made, so we're giving them some extra props because they didn't get back to us. They changed the name of their company and still had vulnerabilities, and we said publicly that changing the name of your company isn't a valid patching strategy, so apologize for that joke. All right, a couple more things. We're going to move very quickly here, but as you can see, a lot of these things are pushing security back on your own developers. So long gone are the days of fixing problems before they get to your developers. So here's another example where we have a twofer. And we found a lot of these where there wasn't just one vulnerability, but two. So not only is it vulnerable to SQL injection, it's also vulnerable to remote code execution. So just keep in mind, they could be shipping these vulns back to you as well. Because a lot of these libraries, and even if they say to run it in a container, it's buried somewhere deep in their documentation. And as we've seen, just putting it in a container is not necessarily a complete fix.
So lack of security knowledge. So I guess, as you know by now, most of what we've shown is lack of security knowledge and expertise. But here's an interesting example. So this project was treating TLS certificates as though they are a secret, but hard-coded credentials, nope. They would just publish them as a public GitHub repository. And that brings us to API weaknesses. So there was this project called Sorcery, which is an AI code review product. And they have integration with something called Sentry. You may have heard of it. It's basically for, well, you can use it for managing and triaging application errors in production. And we found that there was a vulnerability in one of their internal APIs used by their web app that would let us access data in other Sorcery accounts than the one we were logged in as. And since Sorcery themselves use Sorcery for their own source code, and they also use the Sentry integration, we could basically access their Sentry tickets that contained production error messages of the Sorcery app itself. So we could debug their app for them. And sometimes these error messages can contain sensitive info, right? So here at the bottom left, right, you have an example of a GitHub access token of a repository of a user of Sorcery that was leaked. And just as a side note, so when using GitHub apps, if you are a developer of such an app, or even if you use these apps, you should really be careful with what permissions you grant or request. And because these permissions, they are often not well explained. Even on the GitHub website itself, if you don't go look in the documentation, it's not really clear what they do. And Sorcery, they were requesting the right permissions to workflows. And this is a very dangerous permission. Because if somehow we could leak the GitHub app private key, like we did with CodeRabbit, then that would give right permissions to workflows to all of the repositories, and that permission lets you modify the GitHub actions in a repo. And if you can do that, then it's very easy to leak GitHub repo secrets. So yeah, be really careful with what permissions you grant. And throughout this research, we found that it was usually quite difficult to report vulnerabilities to vendors in a private way. Usually they don't have any contact info or maybe even no instructions, but sometimes we even had a case where they had instructions on how to report something to them, but the instructions were broken. So that doesn't help. And some replied really quick, and some never replied to us.
So as you go looking for these things in your own environments, or you go looking for bugs in these tools, there's a few things to keep in mind here. Hopefully you've seen throughout this presentation, so all of these slides are available for download. We didn't sanitize anything other than secrets, so all of the attacks are pretty easy to see inside the slides. I know there's a lot of text on them. But hopefully you've seen how it's not just attacking an AI, it's not just looking at a system, it's understanding how the AI can be manipulated and the system. So it's all about context. You have to understand the tools it has access to, all of those types of things. So talk to your developers, make sure you aren't magically using one of these tools and you didn't know it, and help them understand the risks. Many of these tools need to be tested dynamically, kind of like we tested them. You won't have access to the source code to look for things, and even if you did, it goes to a black box, and you might not know the information that's coming back, so you have to test it dynamically anyway. And of course, assume a larger input scope than you have. And what does that mean? So generative AI is overscoped. It means the same generative AI that gives you a recipe in the style of Shakespeare is also the same one making critical decisions about your code. And this overgeneralization leads to a larger attack surface. So a very simple approach is to evaluate the tools in deployment, understand the use case and how it's deployed. Many times it's not about the capabilities of the AI, but the capabilities of the tools that it's interacting with. Understand and map the inputs. I mean, as you've seen, a lot of these aren't chat interfaces. They're taking data from code snippets, documentation, config files, and many other locations. So read the documentation and understand, the larger scope and the larger picture, and then conduct contextual tests, right, based on that. And that's going to give you a lot more effort. It's going to mean you don't miss things. And you may need to run tests multiple times. These are non-deterministic systems. So you might get a different answer each time, which means running the same test multiple times may yield results. And of course, as we mentioned before, small tweaks in the input can lead to large tweaks on the output. And of course, this was messed up. Another thing to think about as you're looking here is that prompts usually go something like this. You are a super awesome X. Here is some additional context, and that's where user attacker data ends up. Do this thing, and then don't mess this up. So if you think about it that way, you can start thinking about how your information is ending up inside of these prompts. And of course, think of prompts less like rigid specific commands and more like suggestions. Because this has led to a lot of problems. People think that they're actually giving the AI commands when they prompt it. But it's really more like prodding over programming. Use this to your advantage when you're testing. So we have a few recommendations here, but I'll say this over and over and over again. We're a big fan of simplicity. This is a big secret. Most of AI security is just application and product security. These things do nothing on their own. Models do nothing on their own. They need to be put in an application and used in a use case for them to do something. The big problem here is if you don't have a mature application or product security program in place, you're going to amplify the amount of vulnerabilities that go into production. So start prioritizing your efforts today. We're not going to go through what makes a good AppSec program. There's a bunch of information out there on that. But you have to understand where your data is going and where execution is happening, because it's not always obvious. So architecture reviews and threat modeling certainly help in that front. And then help developers understand the risks. Help them understand that they're actually pushing vulnerabilities into production. Another piece of advice that we'll give is don't treat these systems as highly capable, super intelligent systems. Treat them as lazy, intoxicated robots. Because that's a much better way of thinking about how to handle the manipulation risks, the reliability issues. When you think about things this way, it gives you an idea about how to add additional layers of validation, additional tools, additional processes, and possibly even human QA. And of course, this should be the golden rule for generative AI, is that if an attacker can get data into your generative AI tool, you can't trust the output, so design accordingly. One simple piece of advice that we'll give is refrain, restrict, and trap. This is a little old. This is from May of 2023, but it's still a goodie. And basically, it talks about using 3 steps with your generative AI. So refrain from using it in high-risk, safety-critical use cases, critical code, things like that. Once you've decided to use a tool, a generative AI tool, restrict it. Make sure it's got reduced permissions, reduced execution, all of those types of things, so that you've reduced your blast radius. And then finally, trap. So try to use guardrails, trap the inputs, look at the outputs, understand that none of these things are silver bullets, well, other than refrain. I mean, I guess you can't get hacked if you don't use it, but still, understand that you're always going to have to be vigilant here. There are far more recommendations in the bonus content section of our talk.
And as a conclusion, so AI, as you've seen, AI applications are more and more connected and have more and more power than ever before. So if one of these apps is vulnerable, the consequences can be catastrophic, as we've seen. It can go up to getting access to over 1 million GitHub repos. And we've seen that known vulnerabilities, or old school ones, are showing up at alarming rates because of these tools. So we have to be proactive here, right? Because it will only get worse because of practices like vibe coding and things like AI coding assistants. So if you've never had a chance to see what it was like to hack in the 90s, well, now we have a second chance. So
And the slides are available right now. If you want to download them, they are uploaded. They have some additional content in them. Please let us know if you have any questions. We are going to be going to the wrap room, and we'll be happy to answer anything that you have, and we'll stay there as long as you'd like. So thank you very much for joining us.
Thank you.